Good day! In this video, we are going to define what is mathematical induction and use it to prove that 5 raised to n minus 1 is divisible by 4 for all integers n greater than or equal to 1. Now, what is mathematical induction? Mathematical induction is a method for proving a statement, a theorem, or a formula that is asserted about every natural number. It has a principle. So the principle of mathematical induction. Let P sub n be a statement involving the positive integer n. Let m be a fixed positive integer. Suppose first that P sub n is true for n equals m, and second, for all k greater than or equal to m, if P sub k is true, then P sub k plus 1 is also true. Therefore, P sub n is true for all integers n greater than or equal to m. Now, for us to show that 5 raised to n minus 1 is divisible by 4 for all integers n greater than or equal to 1, we will use the principle of mathematical induction. So that is, we'll let P sub n be 4 divides 5 raised to n minus 1 for all n element of n, where n is the set of all natural numbers or positive numbers. So we need to show that P sub n is true for n equals m, and for all k greater than or equal to m. If P sub k is true, then P sub k plus 1 is also true. We have, if n is equal to 1, then P sub 1 is 4 divides 5 raised to 1 minus 1, which is equal to 4 divides 4. And that is true because 4 is divisible by 4. Hence, P sub n is true for n equals 1. Suppose P sub n is true for n equals k. Then we shall assume that P sub k is equal to 4 divides 5 raised to k minus 1, which is the same way as saying as 5 raised to k minus 1 is equal to 4m, where m is an element of z, where z is a set of all integers. 4 and m are the factors of 5k minus 1. Now, assume that P sub n is also true for n equals k plus 1. That is, we shall prove that P sub k plus 1 is equal to 4 divides 5 raised to k plus 1 minus 1. And it is the same way as saying as 5 raised to k plus 1 minus 1 is equal to 4p, where p is an element of z, which is the set of all integers. And 4 and p are the factors of 5 raised to k plus 1 minus 1. Now, we will have 5 raised to k plus 1 minus 1 be equal to 5 times 5 raised to k minus 1. It is the other way of writing this one. So, 5 raised to k, we can substitute 5 raised to k by 4m plus 1. Because in this equation, this can be rewritten as 5 raised to k equal to 4m plus 1. So we need to distribute. That will become 20m plus 5, then copy negative 1. Now, we will simplify. That will become 20 plus m. Add like terms. So 5 minus 1 is 4. So we have 20m plus 4. And then, factor this out. We will have 4 times the quantity of 5m plus 1, where 5m plus 1 is an element of z. And then, that will become 4p, where p is equal to 5m plus 1. So, we have already shown that 5 raised to k plus 1 minus 1 is equal to 4p, which is our goal to show. Therefore, p sub n is true for n equals k plus 1. Accordingly, by the principle of mathematical induction, 5 raised to n minus 1 is divisible by 4 for all integers n greater than or equal to 1. And that ends our proof. This is all for now. Good day once again.